Hello, we are going to do just simple simulation, simple finite element analysis for this 2x2 bar. Uh, we are going to apply some forces vertically, apply some fixed support. We'll be able to assign materials, check the mesh, and find the solution, the stress vortices, and the total displacement. Let us get started. First of all, there is an option in the Autodesk Inventor say stress analysis. Click on stress analysis. Once you click stress analysis, on the left corner on the top, there is an option say create study right here. Click on create new simulation. Once you create a new simulation, there is a window that will pop up. Hit OK. So after hitting OK, you see that on our left corner, we have different options and the different activity we are going to perform just to make our simulation run. First of all, we have a 2x2 bar here. We don't know what kind of material is made in. First of all, let us assign the material on it. Come here to the material, right click, click assign material. When you assign material, every material that's not assigned is just pop up as generic. Let us try to assign material to our bar. Click here. It's already set as a generic as a defined. Let us modify this material. You can pick any kind of material you need here. So I will say, I will use just right here, mid steel. Hit OK. So our 2x2 bar will be made in steel milled. Yeah, you just can just drop it down here. You see that our bar is made in mid steel. The next step will go just to add the constraints. For our simulation, this bar will be fixed to the one end and open to another end. I'm going to fix this bar to this end. From this constraint, go on the constraint, right click, fixes constraint. I will fix this bar right here by this end. Click on it, then hit apply. As you see here a white color that represents that our bar is fixed on one end. If you drop on down here, you will see that our bar is already fixed as it's shown right here. The next step will be to apply the force. I want to apply a force of 10,000 pounds vertically on the top of this bar. Like I say, it's going to be fixed on one end and free to another end. Just bring your mouse on the load here, right click, click on force load. You can apply pressure load, bearing load, moment load, body load, gravity load, the remote force load, but at this time we are going to apply a force load. Click on force load. It's going to be a force, click on the top. It's going to be a force of 10,000, let me say 10,000 pound and hit apply. Close this one. When you drop this plus here, you'll see that we have a force which apply on the top surface of this bar. That means what? We have our bar which is fixed the one end and a force applied on the top of this bar. The next thing will be just to learn the mesh. Apply the mesh on our model. There is mesh option right here. Click on the mesh, right click, mesh view, then click. So it's gonna take a couple minutes. I just try to take a simple example so that should not take that longer, because the more you have more assembly, the more it takes a while to calculate the mesh. As you see right here, our bar has a mesh of 1,337 nodes and 658 elements. So once we have our mesh, it's time now to simulate our part so we can see the results. Here on the top, on the top middle, there is an option say simulate, solve. Click on it, and a window will pop up, ask you to learn. So now the simulation is calculating the results. Okay, awesome. From our result, we should be able to find different scenarios. From result window, I should be able to find the stress vortices, principal stresses, principal stresses. You should be able to find the total displacement and the safety of factor. Now we have different stresses on the different axes right here, and different total displacement on different axes. And we will be able to have a strain here, the last. So like we see on our model, the maximum stress we have on this bar is 7.281 psi. Most of this stress is just condensed here on this junction where this bar is fixed on the wall, because this force is trying to pulling up this bar force. It's of course understandable, it's going to create some stresses between this contact, and of course creating the total displacement. The minimum stresses will be 0.002 psi. So again, the blue represent minimum stress and the red represent maximum stress. Click here on the displacement, double click on the displacement. So like we know, we already fixed our part to one end and apply the force to another end. Since the force has been applied to another end, the maximum displacement will just appear on where this bar is not fixed. As you see, we have a red color here. This red color represents the bending, and which is the total displacement of this bar. The maximum total displacement is 0.04069 inch. Not that too big, but it's just the maximum we have. And the minimum the displacement, of course, is by where there is this bar is fixed on the wall, somewhere on the wall. So you should be able to just double check different scenarios here, like first principal stresses here. We have 10.25 key SI maximum. Principal stresses should be able to check the strain, equivalent strain. You should be able to double check the safety factor. Okay, seems like the safety factor of our model seems to be okay. Okay, so anytime you want to do some modification on your simulation, you can do that. For example, if I want to modify the force applied, I can just come here simply to the force, right click, edit force, change to change to, for example, 5,000. Change to 5,000. Change to 5,000. All right. Change to your force to 5,000. Hit OK. Then again, simulate, learn. Okay. The more you change your scenario, the more even the result will be changing. Then after you got your information, you should be able to finish analysis. Then you're done with your simulation. Thank you for watching. See you in the next video. Bye.